Hi, this is a video for the Tmua 2018 paper 2, question 16. So this question is a really good example of when using small cases to try and spot a pattern is very helpful. And the other thing that's good about this question is it's a they're giving you something that's true. So we know all of the terms are integers, and it's saying if the median is an integer of the first n terms. So what we really want to think about, this is statement A, if you will. So statement A, we are saying if this is true, then, and each of these is statement B. So we're looking to see, does statement A imply statement B for any of these three? Now, we want to get an idea of why the median would be an integer and also why the median wouldn't be an integer. So if we think about the simplest possible arithmetic progression we can have, say 1, 2, 3, just start with one consecutive integers. Obviously, if n is 3, then we're fine. Or if n is 5, then we're fine, because then we'll always have a middle number. We'll have a problem if we've got a even number of terms in the sequence, because then we'll be adding 3 and 4 divided by 2, and we get a median that's not an integer. But if we had, say, 2, 4, 6, 8, it wouldn't matter whether the number of terms in the sequence was odd or even. So we get a bit of a feel just by trying some small cases that the terms being odd or even is going to be really important here. Now, we know statement A is true, that the median of the first n terms is an integer. So if our first term, let's do a little table here. If our first term, A, and we've got a common difference D, and then we've got un, and we know that un equals a plus n minus 1d. If the first term's even and the difference is even, then un will always be even. If the first term's odd and the difference is even, then we're going to always have an odd number for un. So if we've always got an odd number, is that a problem? Well, let's think about that. So say we had 1, 3, 5, 7. Well, actually, the sequence is never going to be a problem if there's an odd number of terms. If there's an even number of terms, as long as the two terms you're adding together are either both even or both odd, then it's fine. So that must be what's happening, because if we have, say, an odd first term and then an odd difference, or an even first term and an odd difference, then actually what we're going to have in both of these situations is a sequence that goes either even, odd, or odd, even. And this is a problem when n is when we've got an even number of terms, so say 4, 6 terms, etc., because then we're going to be adding together an even and an odd. As long as we're adding together either two evens or two odds, we can always then divide by 2 and have an integer. So these two are the potential problems. But let's have a little think about what's going on. So if the median of the first n terms of the sequence is an integer, then we know if A is true, then we've either got A is even and D is even, and therefore all of the terms are even and we're fine. Or we've got A is odd and D is even, and then, sorry, let me put capitals there. or we've got an odd number of terms. One of those things must be true. And if any of those are true, then it's for either of these first two, n plus 2 terms is also going to be fine, because you're still going to have everything as being even. And similarly here, we'll have everything as being odd. It doesn't matter how many terms you have. And if there's an odd number of terms, then n plus 2 is still an odd number of terms. So 1 is definitely true. Now, the median of the first two n terms is an integer. So we're looking for potentially a counter example here. So could we get a case where the median of n terms, we've got an integer, but the median of 2n terms, we don't? Well, actually, this first one over here is an example of that, because if we considered n equals 3, we've just got these three terms and the median is an integer. But as soon as we go to n equals 6, this 3 plus 4 over 2 is not an integer. So this one is not going to be true. Then the next thing is if we take every other term, but we go up until 2n. So say, for example, what this would mean is if we had 1, 2, 3, does that mean that 2, 4, 6 is going to be an integer? So we've got the same number of terms that we're skipping out every other one. Well, if we've got this case here of two evens, then that's going to be fine. It doesn't matter. And the same if we've got an odd for A and an even for D. Or if we've got an odd number of terms, then we're still going to have an odd number of terms. And as long as we've got an odd number of terms, it's always fine. So actually, any of these situations are going to imply that that's true. As long as the median of the first n terms is an integer, then all we're doing here, and if you think your series are either going to be even, odd, etc., or the opposite of that, or all odd, or all even. Now, if they're all odd, it doesn't matter how many terms you have. It's always going to have an integer. The median is an integer, so that's fine. That's fine. And this, if you're only taking every other term, you can see that you're going to have a sequence that's either all odd or all even. So that's always going to be true as well. I hope that's helpful. Let me know if you have any questions.